The Memex Automation Solution Video Series Configurable Adapter. This is the critical component that describes how the signals from the machine are to be interpreted through the actual network. It is a package what Memex calls AxConfig that really does the signal conditioning from the machines through the board into the overall network. It utilizes a package toolkit approach. It's really a utility tool. It involves logic ladders, very similar to a PLC logic ladder, which sets the different logic signals directly from the signals from the machine, interprets those in various combinations to be able to produce a particular output foreseen by OEE. In this particular example, on the chart, we can see that the alarm is green because all the individual signals are actually set as green to be true. And so the classic logic ladder works, and it works together. So it's a very quick and easy way to put it together. Let's spend more time looking at it in real time. Here we look at the AxConfig adapter itself. It is really the data concentrator or central point. We notice here a number of machines are listed in our particular factory. The actual machine numbers are listed here. We know the status it's connected, and so on, with IP addresses and overall communications. If I click on this particular machine, I double click on it, I can look at the actual communications setup of that machine. And now all the standards, MAC addresses, the IP addresses, networks, gateways, communications, ports to deal with DNC host capabilities, what speed that we're needing to deal with on the machine. All this is configured and is set together. We can file those to a particular file for backups. We can file it directly to the board itself. And of course we can save, apply, and do all kinds of things. So the net of it is we can control very much easily the communications of the particular board. If I also look carefully, I have a number of particular other utilities I can do: traffic monitor, command terminals, firmware updates, our emulator for the operator interface, email servers, database viewers, ERP importing capabilities. I can pull this up, know exactly where the ERP system is going to be, and work with that, monitor files that work with, and take a look at different log files in terms of how they work and what they do. So much information is available here about how to work with the actual boards and machines and tools. It's all a utility. Critical to this is if we look at a particular machine itself, we check the I/O setup itself. An I/O setup is currently running. I scroll down here and I can see that I actually have this up and running here. And this is the I/O logic ladder for a particular machine. If I turn it into run mode, we can now see that it's physically collecting the input states and timer states on the particular board, switching into alarm state in particular areas when all the connections come together, e-stop in this particular area here. Again, following the logic ladder principles, very similar to in PLC. This is all easily able to be tailored and adjusted. If we go into the edit mode capabilities here, we look at the actual I/O settings within the edit mode, and I'm presented now with 5 particular tabs that I can look at. The first tab is the input settings. I can track 8 different physical signals here, and these are the physical electrical signals that is connected from the machine. I can set them as low or high. I can debounce the signals if they're flashing lights or any strange anomaly with the particular signal itself. We can condition that signal to understand it here carefully. We can also set particular signals to be auto part count, and it's just a checkbox here to be good or to be a reject count. We can actually set which ones it's going to be. We can also get into an I/O translation, which then defines here what the names are going to be textually in our reporting system through the network. Input 00 would be an e-stop, and this goes into the logic ladder. Same with the software inputs, go into the logic ladder, and we can control those up to 32 different particular codes here. In the timer and signal outputs, we're also defining those same timer names to be able to be communicated and how we're going to see it displayed out through the actual dashboard itself. We can keep track of individual output signals that we can drive here. Again, the same sorts of ones that we can drive those particular signals from the systems. Reject reasons, we can go through in here. We can actually program different rejects reasons and put on as it makes sense, and these set them up. So just very simply here, I could just type in the word demo And that will then carry through onto the dashboard in the rejects for reject number 13 as being that stand 1 for this particular machine. Email messages, same thing. I can list up to 20 different email messages here. The whole email engine would then drive how these are actually communicated out and sent. This is just establishing the actual textual messages per machine that's set up. So with that, what we have done is really physically configured the particular board to be able to communicate for the different information that we need to. We can copy input rungs, we can create rungs, paste them, edit them, delete them, do that sort of area. We can toggle, we can validate the ladder, and validate the ladder simply means it goes through and checks to be sure everything makes sense in terms of the ladder, its status. The ladder is validated, it's connected to the machine, we know everything's working. We can file all the information to a backup file or board. We can keep track of everything. Very simple, elegant way as a packaged toolkit to be able to be sure that we understand exactly how our system is working at the particular machine in our machine network.